Well, this video is for Math 111, and this assignment is on solving systems of equations. So this is review of material. It depends on what courses you've taken, where you might have seen it, either in Algebra 1 or Algebra 2 or Math 70. This first assignment is a review of the process for solving systems of equations. And then in the next couple of assignments, we'll build on that. So if we look at problem 2 here, we've got two equations and two unknowns. So x minus y equals 3 and x plus 3y equals 7. So using this review to cover the methods of substitution and elimination of variables. Okay, so we only have to use one of those techniques on each problem. On this first problem, I'll do both. I'll do one solution based on substitution, one solution based on elimination of variables, and then as you work through the problems, just decide which one seems easiest for each problem and go ahead and do it that way. Okay, so if we're going to do substitution here, we've got a couple of choices here. We could say x, add this y to both sides, and so then x would be equal to y plus 3. And then we can take that and put it into the other equation. Don't put it back into the same equation because that's not going to work. So if we do that, then instead of x plus 3y, we'll have y plus 3 plus 3y equals 7. So 4y plus 3 equals 7. 4y equals 4. And y is equal to 1. If y is 1, then x is 4. And does that work? 4 minus 1 is 3. 4 plus 3 times 1 is 7. Good. Okay. So that's the substitution process. Elimination of variables. Let's see here. So we have x minus y equals 3, x plus 3y equals 7. A couple things we could do here. I'll divide this in two pieces. If we want to eliminate the x's, all we have to do is make one of them negative, right? So if we multiply on both sides by negative 1 here, that'll give us negative x plus y is negative 3. Now add the equations together. There's our 4y equals 4, y equals 1. There's one method. Let's say you wanted to eliminate the y's. Well, then we could multiply the top equation. They already have opposite signs. So multiply the top equation by 3, and now we get 3x minus 3y equals 9. Add them together, these cancel out. We get 4x is 16, and so x equals 4, and you can go back and plug that in and find y equals 1. So again, I've done 3 different solutions here. I mean, we got the same solution every time, but 3 different methods. You just need to choose one and do the problem that way. Okay? Now, different problems might lend themselves to different methods of solution. You might have one that looks easy to solve by substitution. A different problem might be easier by elimination. So just, try to judge based on what the problem looks like. Okay, let's see here. Problem 4. Let's see, we've got 3x plus 2y equals 0. Negative x minus 2y equals 8. Well, this one is set up really nicely to eliminate the y's. All we have to do is add the equations together. This will be 2x, those will cancel out, equals 8, and so x is 4. So let's see here, if we plug the 4 in, 3 times 4 plus 2y equals 0. So 2y is negative 12, y is negative 6. And let's double check that in this equation. Negative 4 plus 12, yeah, gives us 8. All right, so there's problem 4. Let's see here. Problem 6. X plus y equals 7. 2x minus 3y is negative 1. Well, this one looks like elimination. I think I'm going to prefer to do elimination on this. If you come to class and want to see me do use a different method, I'm happy to do that. But right here, it just looks like if we multiply this top equation by 3 on both sides, then that'll give us 3x plus 3y is 21. So now the y's will cancel each other out. We get 5x is 20. And so it looks like x equals 4. So if x is 4, then y is 3. And let's see, does that work here? 8 minus 9, negative 1. Good. Okay. All right, let's look at a couple more of these. Let's see here. Problem 8. 4x minus 3y is 28. 9x minus y is negative 6. Well, I think I'll do this by substitution. I like this y is going to be easy to get by itself. I'll move it over here to make it a positive y, and I'll move the 6 over here so that the y is by itself. So now we've got y equals 9x plus 6. So then we'll say 4x minus 3 times 9x plus 6 equals 28. All right, so we've got the y by itself and then made a substitution back into the other equation. So let's see here, 4x minus 27x minus 18 is 28. So let's add the 18 over here. So that'll be 46. 4 minus negative 20, or 4 minus 27 is going to give us a negative 23x. Divide on both sides by minus 23. X should be negative 2. Let's see, if x is negative 2, 9 times negative 2 plus 6. So y should be negative 12. Okay, so let's see. Negative 18 plus 12 is negative 6. Let's see. Negative 8 here, positive 36 here. 36 minus 8, 28. Okay, so we've got our solutions for x and y. And like I keep showing you, you can check it out by just plugging it back into the two equations and making sure that it satisfies both of them. All right. Oh, let's look at problem 10. Negative 4x plus 12y equals 0. 12x plus 4y equals 160. All right. Well, let's see. I don't want to try to isolate one of these. We could get the y by itself without too much trouble. But if we just multiply the top by 3, then it looks like it should cancel out those x's pretty well. So this will be negative 12x plus 36y, still a 0. 3 times 0 will still be 0. So these will cancel. This will be 40y equals 160. So it looks like y will be 4. And let's see, if y is 4, let's see. Let me find a good place to find out what x is. So y is 4. Then negative 4x plus 48 equals 0. Move the 4x over here. 48 is 4x, and so x equals 12. And did we get y? Yeah, y is 4, x is 12. Okay, so let's see here. Yeah, so negative 48, positive 48 makes 0. Here, 144 plus 16, 160. Okay, so let's look at that last one. Problem 12. Let's see, I think that's the last one. Oh, no, there's a couple more on page 2. All right, so let's keep going with these. Problem 12 is kind of interesting because it involves fractions. So let's go ahead and take a look at that one. There's a variety of ways that you can approach these. Let's see. So, a half x plus 3/5 y equals 3. 5/3 x plus 2y equals 10. Well, let's see. We don't have an obvious situation for either substitution or elimination. Okay? I'm going to use a substitution here. I'm going to get the x in the first equation by itself. Okay? So, if we take a half x plus 3/5 y equals 3, subtract the 3/5 y on both sides. A half x is 3 minus 3/5 y, and then multiply on both sides by 2. And that'll cancel out that 1/2. So x is going to be 6. We have to distribute here, minus 6/5 y. That's not ideal, but we've got a nice solution for x here, and that'll allow us to take this expression for x and plug it into the other equation. Okay? All right, so let's see what we get out of that. So 5/3 times 6 minus 6/5 y plus 2y equals 10. All right, so let's multiply. 5/3 times 6 should be 10. And then minus 5/3 times 6/5 looks like 2y. Interesting, okay, because now we're getting plus 2y equals 10. Well, minus 2y and plus 2y makes 0. So here's 10 equals 10. That's always true. This is one of those equations that is true no matter what the values of x and y are, actually. Although I will say, so like, if x was 0 and y was 1, that wouldn't work. Okay, so I shouldn't say it doesn't matter what the values of x and y are. What I should say is that there are an infinite number of solutions. There are an infinite number of pairs of solutions, x and y, that will make both of these equations true, because in the end, they're really just the same equation. Okay, so I don't want to get too deep into that, but let's just say infinite solutions for this problem, and let's take a look at some of the other ones. If we run into another one that doesn't have so many fractions in it, we'll kind of dig into that a little bit more. Let's see here. Problem 14. 4x plus 2y is 16. X minus 5y is 70. Well, this one is really set up for substitution. You could do elimination if you wanted to. There's nothing wrong with that. I just see it's pretty straightforward to get that x by itself. X is 5y plus 70, and then we're going to go and plug that in to the other piece, so into the other equation. 4 times 5y plus 70 plus 2y is 16. So 20y plus 280 plus 2y is 16. So 22y, and then we'll subtract the 280 on both sides. 22y is negative 264. And so if we divide on both sides by 22, let's see, y here is going to be negative 112. Okay. Yeah. Okay. So y is negative 12, and then x is going to be, looks like positive 12. Oh no, positive 10. There we go. X is 10, y is negative 12. Does that work? Let's see. This will be 40 minus 24 is 16. 10 plus 60 is 7. Okay. So there's problem 14. Just got a few more here. Problem 16 is a good illustration of what we were talking about in that last problem, in the problem before this one. Going back to problem 12, I think it was. All right, problem 16. Negative 3x plus 5y equals 2. 9x minus 15y equals 6. All right, so on problem 16, I'm going to use elimination on this because we've got opposite signs for both variables. So all I would need to do is multiply this top one by 3 on both sides. So this will be, let's see, negative 9x plus 15y equals 6. Now watch what happens when I add these together. This is 0, this is 0, this is 12. So this is saying there's no values for x and y that will make this true. Okay? So essentially, when we do one of these systems of equations, if we think of these as graphs, okay, so in most cases, you'll be graphing these two lines, or you'll be given two lines that you could graph, and they would have a single solution where they intersect. Okay? So this is one solution. Now, problem 12, what we saw was, it was hard to see because of all the fractions, but what we got here was 0, in problem 16, we're getting 0 solutions because both of these are actually the same equation twice, okay? But with a different y-intercept. So this one, negative 3x plus 5y equals 2. Move the 3x to the other side. Y is 3/5 x plus 2/5. Now take this one. 9x minus 15y equals 6. Let's see here. Move the 9x to the other side. And divide everything through by minus 15. So y is going to be positive 3/5 x minus 2/5. Yeah, I thought we were supposed to get different y-intercepts. And we are, okay? One's positive 2/5, the other's negative 2/5. These are parallel lines. They don't intersect. We've got 0 solutions. Okay. The last one is that one that we saw in problem 12. And what happens there is that there are an infinite number of solutions because we're just looking at the same line twice. So let me show you an example of something like that. Let's say we had, I'm going to make it simple, 2x plus y equals 9, 4x plus 2y equals 18. Okay, you can see all I've done is taken the top equation and multiplied everything by 2. These are the same equations, right? If we get the y by itself, this will be y is negative 2x plus 9. This one is also going to be y is negative 2x plus 9. And so this is going to be the same equation twice. Okay? And so there are going to be an infinite number of solutions. All right? So when you're solving an equation like this, what you're going to end up with is a true statement. Like if you add these two together and you get something that says 0 equals 0 or 10 equals 10, then you're looking at two versions of the same line, so you have an infinite number of equations. This one is going to end up like what we just saw, 0 equals 12. Okay, that's not true, and there are no values for x and y that will make that be true. Okay? Most problems that we run across are going to have one solution. They're going to be two different lines that intersect somewhere in one place, and you'll have an x and a y for that solution. Okay? All right, so let's get back and finish up the problems on that handout. Okay, let's see here. All right, problem 18. Two x minus 3y is negative 8. And then 14x minus 21y is 3. Okay. Now, if we take a look at these, now what you'll see here is that if we wanted to cancel these out, let's say we wanted to do this by elimination, okay? Now, both of these have the same signs, plus and plus, minus and minus, but if we multiply the top by negative 7, let's say, then that would make this negative 14x plus 21y, and over here we have 56. So here's another situation where we're getting no solutions, right? Because these cancel and these cancel to make 0. Over here we've got 59. 0 is not equal to 59, no matter what the values of x and y are. And so this one would be no solution. Okay, let's look at problem 20. Negative 25x minus 75y is 100. Negative 10x plus 30y is negative 40. Well, let's see. I suppose we could do this by substitution. We could also do this by elimination. I'm going to substitute here. I'm going to add this 10x to both sides and then add 40 to both sides. So those will cancel, those will cancel. Here we get 10x equals 30y plus 40, and then I'll divide everything through by 10. So 3y plus 4 equals x. We'll take this, plug it in up there. All right, so 25 times 3y plus 4 minus 75y equals 100. So 75y plus 100 minus 75y equals 100. You see where we're headed with this? These 75y's are going to cancel each other out and make 0. And that's going to leave us with 100 equal to 100. We have an infinite number of solutions. This is the same line twice. Okay? And so we can just leave it with infinite solutions. If we want to dig into this a little bit more, we can, but I'm just going to leave that there for this type of problem. Okay, so as you're looking through these, you do have an answer key. So if you're not sure whether you should be getting infinite solutions, no solution, or a single solution, then you can check the answer key. And as always, if you have any questions, please let me know. Thanks.